Forgot to start the recording, so that's what I'm doing. So let's move on to area and perimeter. Now, if we're looking at a 2D object, and I have drawn out this rectangle, the area is always going to be what's on inside of this. Now, this is a 2D object, two-dimensional. The area is always going to be inside of this. Now, if I had a three-dimensional object, let's say a box of ink that I just bought. This is a 3D object. The area is what we call surface area on a 3D object. So that means that it's this area here. It's the area on this side, this side, this side, and this side, plus the area on the bottom. And this is called surface area. So with a 3D object, you have what we call surface area, where you've got to get the area of all 6 sides, add them together. And because I've told you that this is a rectangular cube, we know that the top area is the same as the bottom. The sides here are going to be the same, and the top and the bottom of the box are going to be the same. Now, if this was a square, and I didn't denote it as being a square, then we'd know that all 4 sides are the same here. So just to make sure that you add up all 6 sides when you're doing this. Now, 2D, we're just talking about this area. 3D is called surface area. 3D, instead of inside the box now is going to be its volume. So how much stuff can it handle inside this box? And that will be the volume of this. We're not going to talk about that right yet because we're still on 2D, but I just wanted to show you the difference between the area of a 2D and the area of a 3D. So the area here is going to be inside this area, inside this rectangle. How much can I put inside this rectangle? The perimeter is going to be the distance around the outside. Now, because I am just adding up all these distances, or even if I multiplied the length times 2 and adding the length times 2, the width times 2 here, my perimeter is always going to be just in units. Now remember, the area is going to be the inside, and I usually find it by doing the length times the width. And it doesn't matter which side I call the length and which side I call the width. Generally we call the length the longest side, but it never matters. As long as one is the length and one's the width, we're okay. And because I'm multiplying, let's say I have centimeters times centimeters, or inches times inches, or cucumbers times cucumbers, ever how I measure this, this is always going to be unit squared. So never forget what your units are going to be. In a perimeter, your units are going to be just units to the first degree, just the unit. An area is always going to be unit squared. And then if we were talking about the volume, I want to know what's inside of this, then I need to do a length, which is here, a width, which is here, and then I need to do the height. So I'm multiplying my length times my width times the height of this box. So I'm multiplying 3 units together. So when we do volume, it's going to be units squared, units cubed, blah, because I'm doing length times width times the height. Now, different books may call it different things. So you just need to make sure that whatever book you're using, that you know, but volume will always be whatever unit you have, and it will be considered units cubed. Now, I'm going to show you this, so I don't have to draw this out. But in your book, this is on page 506, as you can see. And these are called Making Measurements in Non-Standard Units. And what they did is they want you to find the area of these different diagrams, A, B, C, and D. And what they did was their unit here is this half of a triangle. So you can see as you're looking at this that this half of a triangle, if I was to pick this up or cut this out and put it here, that it would divide this triangle just right in half. So A is actually going to be just 2 units of this shape. So when I'm looking at this and I try to figure out this one, I know that these are already in that same, this one's just flipped over, but it's the same shape. And we just found out that one of these whole boxes makes 2, so that means there's going to be 2 in here, 2 in here. So I've got 1, 2, 3, 4, 5, 6 units that are going to be in part B. Now, the unit has changed for C and D. So in C, we've got this new, oh, that's not even better. There we go. We've got this new unit. So you need to look at these. So for C, you've got this unit that's the whole rectangle. So you need to look at that and then look at D. And I'm going to let you look at that for just a moment as I cover up the answers down there. So whether you are looking at, whether you cut this out, draw a picture and cut it out, you can just start placing this. And so I can just turn this one sideways, flip it over. So I've got 1, 2, 3, 4, 5, 6. So that means that our shape 6, picture C, has 6 units. Now D, though, is a little different, because D actually has some that are, looks like that they are half. So I would count the whole ones first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then take and say, okay, well, can I flip this part and it fit into this part? So can I take one of these and flip it to fit into the other? And if we can, because we see what they did was they actually just cut down the center here from the top point down. And because they dropped a, what we call a perpendicular line, it will be the same distance on the base that they cut in half. And so we had 16, 17, 18. So we have 18 units in part D. And you can see the diagram that they did here. They just took this little piece that was over here and dropped it over here into this side. So that made 2 more full triangles here. So that is the way of looking at it when we're not having like a definite inch or whatever. We could have different shapes that we're looking at that we're having to fit into these. Now the and this is what you just did, so don't freak out as being another thing. Congruence of 2 regions in a plane. You just showed this, that if R and S are regions in a plane that have the same size and shape, then they are congruent, and we use the symbol, this equal sign with a little squiggly line on top, to write that R is congruent to S. So the second one says that if region R is congruent to region S and the 2 regions have the same area, so then the area of R is equal to the area of S, which makes sense. If everything is the same, all the sides are the same length, then that means the area on the inside of the shape is going to be the same. So the areas are going to equal to each other. Now, we see how this one was broken down. We've got a hexagon here, and then we have a hexagon here that has different categories. What if I knew the hexagon here, and I knew its area? How could I show that this is the same area? Well, that is by using what we call the addition property. And so, when you have the addition property, then you are saying for the sub units are added and I know that's not mathematical, but it says that if a region R is dissected into non-overlapping subregions, then the area of R is the sum of all the subregions. So if you have subregions or subunits, subregions is probably a better word here, sorry. If you have subregions, just like with this hexagon, and I know that if I were to take it and I were to divide this, this would be divided into 6 triangles. 1, 2, 3, 4, 5, 6 triangles. Well, if I'm looking at this, I've got one triangle here, So this would be the area of this first plot would be 1 triangle. The area for this one would be plus 2 triangles, and then plus 3 triangles. And so they would have altogether an area of 6 triangles. So that's all the addition property is saying, that these 6 triangles that are here may be in a different format, but when you add them, you're going to have the same area in both places. Now, when we look at the area of rectangles, and I do have some graph paper, but I'm not going to pull it out. So if I were to look at this, and I have this this width, and then I divided these up, and assumingly the same, and I'm left-handed, as most of you know, so my lines are a little slanted, and I apologize. I'm not looking directly at this page. But let's say these are all equal. So I have 1, 2, 3, 4, 5, 6. So I have 6 on the bottom. They're the same size as these going up. I have 3. So the area of my rectangle is going to be 6 times 3, which is going to be 18. So the area of the rectangle is 18 units. So what if I cut this in half? So if I cut this in half, then I've got 1 and then a half of another one. And I'm only now looking at this new rectangle that I have. So now, instead of my width being 3, my width is just 1.5. But my length is still 6. So here, my area is going to be 1.5 times 6. So it does not matter what my area, what my length or my width is. That's how we always find the area. Now on here, if I were to count, I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 units. So instead of me counting each one as I go through here, I could just say the length times the width, and that would give me the 18 units. Same thing with this, because it's going to be hard to count. I got 1, 2, 3, 4, 5, 6 whole ones. Well, this half and this half make 7, 8, 9. So when I multiply, I should come up with 9. So depending on what the units are and how it's divided, area of the rectangles is always denoted by length times width. Now, on a parallelogram, which is drawn like this, and it looks like a circle, like a square that just kind of, a rectangle that just kind of whoop, it kind of did a stop too fast, and so it was going along and whoop, it kind of did back. So it's kind of like got this stutter step in here. But if it was drawn to scale, which we know my drawings are never to scale, to find the area of this, it is what we call base times our height. Now the base is going to be this. Our height is going to be when we drop this perpendicular here. And a perpendicular is when I drop a line to the top to the bottom, and it forms this right angle down here at the bottom. And so this is my height. Same thing, if I move that one up, this would also be the height. So this is labeled H. This is also labeled H. And the B can be either 1 Because if it is a parallelogram, then the base should be equal and the height's going to be equal. The other sides are equal to here. Now, I always try to draw this on the board. But if you look, this is the parallelogram in the book. And the reason we can do the base times the height, which is essentially length times width on a rectangle, is because if I were to take this little piece here and flip it over and put it here, this makes a rectangle. So that's how we can say the base times the height, which in a regular rectangle would be length times width. But in this one, it's base times height. And that's going to be how we find the area. Don't forget, though, we always have to be given this height. Now, if I was told that the area is, that if the area equals 36 centimeters squared, let's say, and the base is equal to 12 centimeters, then yes, you don't have to be given the height. You should be able to figure this out because, excuse me, if we know that the area is equal to base times height, we know that the area is 36 centimeters squared and the base is 12 centimeters squared, and I'm looking for the height, then all I need to do is divide by the 12 centimeters squared. This is just centimeters, sorry. And I end up with 3 centimeters, which ends up being my height. So if I go backwards, I could say 3 times 12 equals 36. Centimeters times centimeters is going to equal centimeters squared. So if you're given certain things using this formula, you should be able to find what's missing out of that. Now triangles, just as we showed up here, I could take part of this triangle, and part of this parallelogram, and move it over to here to form a rectangle. Well, if I had a triangle, let's say, like this, and then I took this same shape and I flipped it, then it's going to give me a total square. So a triangle, the area for the triangle is going to be 1/2 your base times your height. Because as I just showed here, a triangle is just going to be 1/2 of our square or rectangle. So that's why we do 1/2 base times height. So let's say that we have I'm not going to draw them out. I'm just going to put them right here and cover up these sweet answers. So find the area of the triangle and the distance V and W. So V is here, W is here. So on A, what we're going to look at is we're going to find, look at this one. On A, what we're looking at is what are we given? We know that area is going to equal 1/2 base times height. We are given a base of 14 centimeters, and we're given a height of 7 centimeters. So I know if I plug those into my formula, I've got 1/2 times 14 centimeters over 1 times 7 centimeters over 1. And remember, I always like, if I'm multiplying by fractions, to have everything in a fraction format. So I can easily say 2 goes into 14 7 times. 2 goes into 2 1 time. So now I have 7 times 7, which is 49, centimeters times centimeters, which is centimeters squared. Now, that's the area for this whole thing. Let's look at the area for V. When I drop this perpendicular down from here, down from the top down, it's going to cut this in half. So I know that now this side over here is actually going to be 7 centimeters. And if you were to take this, and I'm going to try to turn my page like this, then this makes its height here. And so they're showing that if you take the formula and you do 1/2 base times, they're saying the height here is 7, the base is 10, the base is 10, the height is 7 from this, then you get 35. Is that not what I did? Oh, sorry. I used this as the base instead of this. So they're using the 10 as the base, and you end up getting 35 centimeters squared. So its area equals 1/2 10 centimeters times 7 centimeters. Once you find that, then I know that the area is going to be 35 centimeters squared. So then what if you flip it and decide, okay, 14 is going to be my base, V is going to be my height, so that's what they're looking at. So you're doing A equals 1/2 base of 14 centimeters, and then the height of V. So 1/2 times 14 is going to be 7 centimeters, times V is going to equal the area, which we know is 35 centimeters squared. So if we divide by 7 centimeters, then we're going to have 5 centimeters equals V. Now, here you have a trapezoid. All of these are the same thing. The trapezoid, though, is I've always learned this formula by saying the base 1 over base 2. So it would be the area is going to equal 1/2 b sub 1 plus b sub 2 times h. So you're doing the same formula, but now here, because it's not a triangle, it's actually a trapezoid, these two bases are parallel to each other, and because of that, we've got to add them and then divide them by 2 to get the length of our base. So that's why we do this. These are two different bases. We add them together because they're parallel, and then we divide it by 2, and that gives us our base, and then multiply it times our height that we're given. Now sometimes on a trapezoid, one side may be totally straight, and so of course that's going to give you your height. You don't have to do anything special for that. Areas and perimeters. Remember, no matter what unit you're using, the perimeter is always going to be the distance around. The area is always going to be the amount that's inside. Now, on a circumference, that's the distance around a circle. And so it's kind of like the perimeter around an object. Sorry. So the circumference and I think about these because I know circumference is like perimeter, so I know the units have to be just in units to the 1. So I know that the circumference has to be the diameter times pi, or pi times the diameter is going to equal the circumference. Now, if I'm given the circumference and I'm given the diameter, then pi is going to equal circumference divided by diameter. So this is your original equation, and I can just manipulate it. So I can say C over D is going to equal pi. And pi, in most cases, when you're doing your homework, if it asks for an approximate, you're going to use pi as 3.14. If it asks for an exact answer, then you're going to use the pi symbol. So for an approximate, you're using pi as 3.14. For an exact, you're never going to put in the pi key, but you're using pi. Now, if they ask you to figure it out and round to a certain digit, then yes, you would put in the pi key. But generally, if you have an exact answer you have to give, then pi is going to be the symbol you're using. And on my labs, when you're looking down at the bottom and it gives you the symbols and other things, in the bottom right corner, I think it is, it'll say more. If you're not given the pi symbol, you can just click on the more, and it'll actually add more symbols to that. So then when we're looking at the area of a circle, I know the area is always going to be units squared. And because of that, I know that I've got to multiply something. So this is going to be area equals pi r squared. So I'm multiplying the radius times the radius. So that gives me my units squared times pi. Now the same thing goes here that goes up here. If it asks for a decimal, then more than an approximate answer, and round the decimal to 2 places, then it wants you to use 3.14. If it asks for an exact answer, then you use the pi symbol. So pi times diameter is going to be your circumference. Pi r squared is going to be your area. Now don't get this confused, because two times the radius is the diameter. So another way you may see this is circumference equals 2r times pi, because 2 times the radius is a diameter times pi. Don't get that confused with this, because the 2 is in a totally different spot. And it won't give you the correct answers. So let's say that we have a radius equals 6 centimeters. I want you to find the circumference and area. I'll be right back. So the circumference, remember the diameter is 2 times the radius. So if I know that the radius is 6 centimeters, then I can keep it as radius, or I can say then that the diameter is going to equal 12 centimeters, because the diameter is going to equal 2 times 6 centimeters. So that's going to be 12 centimeters. So the circumference for this is going to be 12 centimeters pi. If that's an exact answer. If it's not an exact answer, let me get down my calculator. And all I'm doing is 12 times 3.14. And I get an answer of, so my approximate answer is going to be 37.68 centimeters. My exact answer is going to be 12 centimeters pi, or 12 pi centimeters. So for the area now, I have pi r squared. I've been given the pi, the r is 6 centimeters squared. So I have 36 pi centimeters squared for an exact. And then if we do 36 times 3.14, I have an approximation for an area of 113.04 centimeters squared. So any questions about that? Do I still have anybody with me?
Yes, I'm here.
Yes.
Yes.
So we're okay with
Yeah.
area and perimeter. Okay. The Pythagorean theorem. Now, the Pythagorean theorem can only be used when we have a right triangle. And when we have a right triangle, it does not matter where that right angle is. We will always have this little symbol, or you should have this little symbol in the corner to make a little box area that shows that this is the right triangle. This is the right angle here of this triangle. So some of them may be really short and squatty, and it looks like we've got more than one right triangle. But as you know, we can't, because the total area, the total of all the angles is going to be 180 degrees. And if I have two right triangles, that's 180 degrees. So no angle can be that. Now, if I look at these angles, I can always flip them. So I can flip this one to look like this, and then I can just flip this one over to look like this. So you can always rotate them to be in whatever position if you're used to looking at them, whether the right angle's on this side or whether the right angle's on the right side. It doesn't matter. Just always know that the angle, excuse me, the side across from the right angle is always the hypotenuse. So this one is generally always what we call C. It doesn't matter which leg you call A and which leg you call B. But the Pythagorean theorem says that if I take side A and square it and add it to side B that I had squared, that's going to equal side C squared. Now, some of these are pretty common, and you know, one of them is if A equaled 3 and B equaled 5, then C is going to equal what? Or excuse me, B equals 4. A equals 3, B equals 4, and C equals what? Well, you can always, and I always suggest drawing out a picture. So I'm going to let this be the length 3, this one be the length 4. And if I have 3 squared plus 4 squared equals C squared, then I've got 9 plus 16 equals C squared. 25 equals C squared. I take the square root of C on both sides, square root of C and the square root of 25. Square root of 25 is going to be 5. The square root of C is going to be C. So C equals 5 units, whatever we're talking about. But this is a very common triangle, a 3, 4, 5. So Where's my orange rainbow? That's what I would call it. It's a little straighter. Okay, so this is going to be my right angle right here. And this is triangle ABC. Here is X. So we've got a side length of 37 and here a side length of 13. So now you need to find what is X. First thing I would do is say, okay, this is a right triangle, and the side across from the right angle is going to be our hypotenuse. We haven't labeled side X here, but it can be labeled side whatever, but the book calls it X. So I know that 37 squared plus 13 squared is going to equal X squared. So 37 squared on your calculator, you should find out that it's 1,369 plus 13 squared is 169, and that's equal to X squared. Now when you add these two together, 1,538 equals X squared. We're taking the square root of both sides. And when we did that and then rounded it, it was 39.2 equals X. So this length is 39.2. Now, another thing to remember is that when you have a right angle and you're using the Pythagorean theorem, side C is going to be longer than A or B. Now the next example I want to do is just a little bit trickier because you're looking at a box. You're given this as a square. Now, this is a rectangle. I call it a square, but it's a rectangle. And we know that opposite sides are going to be parallel and opposite sides are going to be congruent. So if this is 52, this is 52. Y is Y. And we're given that this piece coming down the middle here is going to be 65 degrees. My question to you is find Y. Now, you can use the Y that's up here, noting that if this is a right angle, then this one also has to be a right angle. If this is a right angle, this also has to be a right angle. So if this is a right angle, then the 65 is actually going to be our hypotenuse. So our C is going to equal 65. Now, it doesn't matter which side I use. I could say that A is going to equal Y and B is going to equal 52. Because I don't know at this point which one's longer or shorter, and it doesn't really matter which one's A or B. I just know that when I square this and I add it to this squared, and then I take the square root, I'm going to get this. So we have Y squared plus 52 squared equals 63 squared. 65 squared, sorry. And then if I wanted to solve for Y, I would have Y squared equals 65 squared minus 52 squared. And then y squared is going to equal 4,225 minus 2,704. Y squared is going to equal 1521. Then I take the square root of both sides, and that one actually comes out even as 39. So that means that this length of the rectangle is going to be 39 units, whatever we're using. Okay, so let's move on to volume. Now, volume, I've always told you, and if you look inside my drink, the volume is going to be, if I had this all the way up to the top, then what's the volume of this container? This one's going to be a little different because it does not form a 90 degree, and I'm not going to turn it sideways, but if I can kind of turn it, you can see that there's a little curve here, so it's not a 90 degree thing. If you have your drink can or whatever, or a can of whatever, you can see that I have volume. I have surface area, which is the area on the outside that we've talked about, but I also have the volume, which is actually in the side of that. Now, volume is also going to have units cubed. So generally the formula for volume is going to be base times height times length, or base height times length times width times height, base times height times length. It doesn't matter how you do it, as long as you're doing the three different combinations. You're doing a base, you're doing a width, and then you're doing a height. So we have I'm going to try to draw a little box here. Of course, I can't draw worth a toot. So we have a length and a width, and then this is considered a height. Some people will actually do length times width, and that'll be their base. And then they'll say base times height is going to be what the volume is. So length times width times height. Some will be the capital B, call this a base. And your base is length times width. So if you see that capital B, and that's going to be length times width. So some spaces may say capital B times height, and that means that you're doing the length times width to get your base, and then you're multiplying it times the height. Now, what happens if we have a cylinder, like I said? So let's say that we just got a can of peas or whatever. And we know that the height of those P's is going to be 9.5 centimeters. And the top of the can here is going to be 5.5 centimeters. The first thing we're going to do is we're actually going to find the area of this. So we're finding the base just like we would have up here on this cube. We would have found the area of the base and then multiplied it times the height. The same thing we're going to do here is that we're going to find the area of this base, which of a circle, the area of the top that I have here is going to equal pi r squared. So I'm going to take, putting on my glasses, so I'm going to take 5.5 divide by 2, because remember the 5.5 is my diameter all the way across. So my radius here is, the radius equals 2.75. Now I'm going to square that, and that gives me 7.5625. 7.5625. Now, if I want to keep this as an exact, and a lot of places do because I want to have the most exact answer, so this is r squared, then my area for the top is going to be 7.5625 pi, and that equals the area for the top of my can. And then what did we do to find the rest of our area? The area is going to be times the height. So I'm going to say this times 9.5, and the volume is going to be 5.5625 times 9.5 times pi. So times 9.5 equals 71.84375 pi. If you want to times that by 3.4 to get an estimate, then you get approximately 225.589375. And on your homework, it'll actually say round it to so many digits after you do it. So our exact answer here is when we multiply and just keep it times pi. Here is when we're going to multiply times 3.14 to get our approximate that we found. So to find the area of a cylinder, or the area of a cube, the volume of a cylinder or the volume of a cube, you take the area of its base, and on a can, the area of the base can be at the top or the bottom. You find the area of that, and then you multiply it times its height, because in every little thing right through here on the can, it's going to have that same area. And remember where we added up our areas a while ago? So if we had little regions, then I could do this. So if you come down to the next one, there's going to be 9.5 little areas in here that are the area of 7.5625 pi. And so you've got to multiply that times 9.5 times in order to get that. So any questions on volume of So on page 536, I'm actually going to bring the book back over again because I don't really think y'all want me to draw this. We have this diagram here. We have the height at being 10. We have the length in front of being 20. We have the width in the back, toward the back, being 20. But we have this little groove cut out in all 4 squares. It goes in 5 centimeters on both sides. So from the front, 5, from the back, 5. And it cuts out that whole little column of work there. So what would you think the volume of this thing would be? How would we go about this? So first, we know that we've got a rectangle. This is 20. Well, if this is 5 here and this is 5 here, then I know that my total is going to be the 20 plus 5 plus 5. So it's going to equal 30 centimeters. Same thing going back is that if I know the width is 20, then I know I've got 5 centimeters here and 5 centimeters here. So that means that I've got the volume of 30 times 30, or let's just say the area of 30 times 30. But the problem is that I've got these little things cut out. So what do I need to do with those? So if we look at this, I know that I have a 5 times a 20. That's going to be the area here. And a 5 times a 20 here. So if we have a 5 times a 20, 5 times a 20, 5 times a 20, and 5 times a 20, that's going to be 5 times 20 is going to be 500, and then times 4, five times 20, sorry. 5 times 20 is going to be 100, and then times 4 is going to be 400. So if I take this, I've got 30 going this way, 30 going this way. So it's 900. And then I'm going to take 400 out of that. So I have 500 square feet that I'm looking at. Oh, I see what they did. They actually made this a rectangle, this a rectangle, that a rectangle, and that a rectangle. Sorry, I was trying to think how they got it that. So this inside piece is going to be a rectangle, and it's going to be 20 by 20. There goes my crazy dog. 20 by 20. And then as it goes through, it's going to cut this off. So I need to catch that, and also we are out of time for today. But be hanging on and looking for anything that's got any information about your test. And you should be finishing up the homework for this unit. I will double check and make sure everything's a go for a test later today. Or later this week, sorry, not today. Okay, have a good day. Goodbye.